plow through some, and if you have, I'm gonna use a red pen, or like if you have something that has a different color, because when I give you the formulas, I'm gonna use this to highlight one piece that is the most important in every single scenario. So have something like that ready. Mark, do you mind turning off the lights for me? You're going to need your calculators too, most likely. First it's just formulas, then it's diving into. Okay, so page 10. Recall that angle, angle, side, angle, side, angle, and side, side, angle all end up forming a pair, which in turn indicates that sine law is required. Okay, so you are probably wondering, why does it always make such a big deal that it's sine law, right? Have a pair, it's sine law, because now we're going to have to choose between sine law and cosine law. The two other cases you may encounter and cannot be solved using sine law are side, 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 so not a single angle given, right? So I go check, check, check like this, right? Or given an obtuse triangle, same thing. There you have it, right? And then the other case is side, angle, side. Notice that the key here is that the angle is sandwiched between the two sides that are known. So it could be anywhere here. It could be that you know this side, and the angle that's in between those two sides. You know it's cosine law at that point. There's no pair, right? There's no way you can get a pair out of this situation. So that's another way to know, yeah, this is cosine law, right? So same here. Let's see. We take these two sides, for instance, and we would know the one in between. That's also side, angle, side. Okay? SAS, right? There we go. So here are the formulas. So the first case is the SAS. Okay, in these cases you do not have a pair, which means you need to use the cosine law. SAS, two sides, the angle is sandwiched between. So I'm going to give you three variations of the formula. And I wonder if I should maybe not do that. I often wonder, is that going to confuse you? But let's do the first one at least. So let's say you want to know this side right here. You would start like this. X squared, that's when I use my color, okay? So if you want to know this side, okay, that means let's put a check mark here, a check mark there, and a check mark there. Let's assume for a moment we know these three. So that allows us to find the side across from it, right? So you go x squared, then you go c squared plus y squared. Doesn't this look like Pythagorean theorem? But this is where it takes a turn. Minus 2 times c times y times cosine of that one angle you know, right? You only know one angle there. Oh, that's where I wanted to use the color, sorry. Because I want that to stand out. You notice the two reds are, that's x and x, right? One is a capital, that's the angle, and this is the lowercase right there. Let's see if you can fill in the blank. So let's say I wanted to find y squared. I wanted to find what the side y is, this one right here. I would then go, what are the other two sides? C and x, right? So we c squared plus x squared minus, what are the two sides that are going to be multiplied by 2? Earlier was c and y, right? See that? This would be c and x, exactly. That's why I like writing it out in various formats so you see the pattern, right? And then it's cosine of what? Angle y. There we go. Perfect. Let's do the last one. So the one other side we still haven't found is c, right? So c squared is equal to, and the order doesn't matter. Like it's just the other, I call it the other two sides, right? So if this is the one you're finding, then it's y and x. So it'd be y squared plus x squared minus 2 times y times x times cosine of angle C. And there you have it. You really, if I'm going to do this, if you add this to your study sheet, you should be good to go, right? I wouldn't write out the other two versions. That is just to let you see what is the pattern here when I'm working with cosine law. And this one is SAS. So this is SAS. When it's that case, when you have the angle sandwiched between the two, you will use this formula, this version of it. I will show you another one coming up. Ready? Ready, Freddy? So this is cosine law. Some students like it more than sine law. They don't have feelings, you won't hurt them, right? The only thing is you must choose between one of them when you start. Once you've solved for one thing, you can now decide which way you want to go. Then it's open country, right? But at the beginning, you have to say, is it this or is it sine law, right? Let's go the SSS case. Side, side, side. And if you have all three sides, you're not solving another side, right? You got them all. So what's left to solve is for an angle, right? You want to start solving for angles. So here we go. So let's say you know all three sides. Let's say you want to solve for this angle right here. This is how you would start. You would say cosine of, and guess what? I'm going to use that angle x is equal to, and that's when you make a long line here. We are basically rewriting the equation I just gave you, and we are isolating for x, for cosine of x, right? So the first thing you want to do is obviously write down cosine of the angle you're trying to find. And then you want to write this one down first, minus the side across the angle you're interested in. That is what I write down first and foremost. And then the other two sides, which would be c and y, correct? Those are in front of it. So c squared plus y squared. So write this down first, subtract. This is the one that's subtracted. Remember, they're all squared, okay? Some students write the formula down the wrong way. They're all squared. Divided by 2 times c times y. Notice that this side does not show up again. Side x only shows up once, right? The side across the angle shows up once and it subtracts, okay? And there you have it. Let's do another version of it. Let's say you wanted to solve for angle C here. That would be cosine of C, okay, is equal to, what's the first thing you're going to write down? You guessed it, minus C squared, okay? And then you grab the other two sides. So it's y squared plus x squared. Divided by 2 times, I just go exactly in the order I wrote this down just to get that right. Even though it doesn't matter, x, y, y, x, 2 times 3, 3 times 2, same thing. Let's do one more, cosine of y, right? We haven't found angle y just yet. Oops, wanted to do that in red. And that is, you can put that long line down, and that is negative y squared. And then you grab the other two sides, c squared plus x squared, 2 times c times x, and there you have it. All three variations of the formula. I don't do it at the beginning because I'm going to scare you, but I will show you the proof, like proof why this works at the end, okay? At the beginning, I think you're all going to be like, Mr. Dixon, just leave me alone, right? Can't handle it. Because it's a longer proof. It's like half a page or more. But they want us to show you why that works. So if you want to add to your study sheet, I would just do one version of it, right? This is what I use when it's side, 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 okay? I want to highlight a few things. Doesn't it look so professional, these little bullets on the side here, right? I want to sell these one of these days and make money and retire early. So I try to make it look all professional here. I have to fix the typos, of course, right? Note, if it's a negative numerator, right, you will have an obtuse angle. You're guaranteed that this thing will be obtuse. Like if you type in the top here and you get a negative, don't freak out, don't panic. It's telling you something. It's telling you that it's going to be an obtuse angle. And another here, when you solve an SSS triangle, I want you to start with the largest angle. Why would that be? Well, there's a problem down the road with sine law. So if you figure out the largest angle, if that's potentially an obtuse angle, cosine will take care of it. Sine law doesn't know how to do it. So if I don't tell you specifically solve for this angle, start with the largest, more later, okay? Can you describe your calculator? I just want you to see it. I want you to see it. Let's clear our screen. And we're going to go second cosine. So we're going to take the inverse of a negative number. So let's go negative 0.3, close brackets. If it's negative, I can already tell you it's going to be greater than 90, right? So let's go ahead and find out. It's 107 degrees, right? If you were to go second cosine, like the inverse, and go 0.3, if you miss that negative, you're going to get an acute angle. So you got to make sure you don't miss that. What do you think these two add up to? I wonder. Can you predict? 180. So what happens is if you forget the negative, it's going to find the acute angle. So sine law and cosine law, they kind of look at it this way. They imagine this point right here. If you give it a negative, it's going to find this one, the obtuse. If it's positive, it's going to find the acute, because that's the difference between finding this one and that one, is whether or not you're adding the negative. Only cosine can distinguish, right? Cosine distinguishes between acute and obtuse angles. Okay, that's a big added here. Added bullet there. Anyways, let's go and actually use this before we have time. We have time. So now we're going to put this to the test, okay? So by Monday, you better have these formulas on your study sheet. Try to compress them. Don't use up too much room, but at the same time, you want to make sure highlight this, right? On your formula, I would highlight this or use a color, right? So that it stands out, okay? And maybe put a little arrow. Don't forget subtract, right? Because some students go plus, plus, plus everywhere. So gotta make sure you get it right, okay? So let's go and solve. Page 12. I think I'm going all out here. Go back to sine law. Yeah, I do. No, don't mix it up. Well, we need to mix it up so that you understand how it works, okay? So side angle side examples. I will say this. Cosine to find side. That's basically what we're doing first. We're going to use cosine to find a side. Okay, so here we go. You look at this triangle. You may have to sketch it first, but in this case, I gave you it, right? So you have side, angle, side. You should recognize that. You've got two sides and the angle in between. So this is side, angle, side, cosine law. Note that you have no pair, correct? You could have just been like, let's try to find a pair. Can't do it, must be cosine law. Same reasoning, just different methods, right? So let's go and solve for side P here. I'm on the wrong page. Oh yeah, I'm on the wrong page. Oops, there it is. Anyways, if I want to solve for P, let's write out the formula. You don't need to do this normally, but P squared would be R squared. So let's put an R here and a lowercase q there so you know what I'm talking about. R squared plus Q squared minus 2 times R times Q times cosine of angle P. And let's plug in. P squared is going to be 5 squared plus 8 squared, and I use nice round numbers here, even though they will be decimals down the road. 2 times 5 times 8 times cosine of 70. And here's where you need to make sure you know how to type this in, okay? Your next line will be like this, folks. Remember, if you want to know what P is without the square, you're going to have to square root. So I do that right away. I don't wait till the end, because you know what happens if you wait till the end? You forget. Okay? That's the common mistake. So let's grab our calculators and just go 5 squared plus 8 squared. I kind of do this in one shot. I don't separate it. Minus 2 times 5 times 8 times cosine of 70. I type it in all in one, just like that. And then hit enter. And we're going to use all decimals, but we're not going to write them all down, right? We're just going to do this. And last but not least, you go second square root. I think you could just hit enter, right? You don't have to go copy it, or I'll try it. Oh, it doesn't like it. I have to go copy it. Okay, fine. I have to copy it into the root. And then it's 7.85, and we are in centimeters. Okay, so that's it. That you've solved for side P. Solve for angles R and Q. Okay. Note, I will make a note here. You now have a pair. Did you notice that? You can use sine law. You can use sine law, absolutely. But I'm gonna stick with cosine law because you're new, right? You're new to it. What's happening here? Too many wires. There we go. So this was A. Let's go. We solve for A there. if I go for B, I'm going to solve for angle. Which one is the largest angle here according to our triangle? We just figured out that this is 7.85. Right? So it stands to reason that Q is going to be the largest. I'm going to just go for that one. Okay. So I'm going to go cosine of angle Q would be, the first thing I write down is minus Q squared. For today, I'm using the formula so that you know. And then you grab the other two sides and square them. Make sure you square them and add. Let me just scroll down a bit here. And then it's 2 times R times P in the denominator. So here we go. Cosine of Q, R squared would be 5. P squared is 7.85 squared minus Q squared, which is 8 squared, minus, right? Divided by 2 times R, sorry, that's 5, not 2 times 5 times 7.85. And there you go. And I'll show you what I do here. I normally don't like trains, but that's okay because when you type all of this in, I will do it separately. I will do the top first. This is the one where I don't like to do it in one shot. So it's 5 squared. Where am I here? 5 squared plus 7.85 squared minus 8 squared, which, right, we know it's 64. It ends up being positive. Okay, so we write down the whole thing. Okay, then you do the bottom, 2 times 5, which is 10, right? Times 7.85, we've got 78.5. And then you go like this. Cosine, or can I do it in one shot? I will do it in one shot. Saves you room. I can now say that angle Q, as soon as you drop the cosine on that left side, you need to take the inverse of the other side because you're basically taking the inverse of both sides. That's why this disappears, right? And then we just write down, I divide this on my calculator. I go top divided by bottom, which is 0.288, and it keeps going. And my last line is going to be figuring out what the angle is. So you go second cosine, go copy your previous entry or answer, I should say, and you get the angle, and that's 73.25 degrees. Boom. Okay. It also wants angle R, sorry. Angle R. You're more than welcome to use cosine law again, but why would we do that? We already know two angles, right? Use the sum of angles. Minus 70 minus 73.25. If you get an error of any sort, I'm just going to tell you check your work, okay? Like there's a chance that you forgot to square one of these. There's a chance that you put the wrong numbers in somehow, so you got to double check your work, okay? 180 minus 70, that's 110. That's 36.75 degrees. So you've answered it all. Oh, calculate the height of the triangle. Do you remember how to do that? Anybody? Let's see if you remember. See if you remember. I'm going to go back to my diagram to show you. You have two options. In this case, you do have two options. Let's draw our height in here. And the height is always measured at a 90, right? I will write in what else I know. I know that this is 36.75, but I'm going to use red so you can tell that I solved for it earlier. So you have a choice. You can go 5 times sine of 70, right? 5 times sine of 70, or you can go 7.85 times sine of 36.75. I'm gonna go with this. Just in case I made a mistake here, it's not going to carry over, right? So I'm going to go with this. Height is, I'm going to go R times sine of angle P. And if you left earlier yesterday, I bet you're not here right now, but I made a mistake on that formula in the booklet, right? It's sine, it's not just R times angle P, it's R times sine of angle P. So we have 5 times sine of 70. And we have 4.698, so that'd be 70, and we are in centimeters. Okay. That's the height of the triangle. You can try the other one to see if you did things right. 7.85 times sine of 36.75. Same thing, round it, right? 470. So you know you're doing things right. So you basically solved the triangle, right? You did solve triangle. You could have gone sine law if you had wanted to. Sometimes you're off by 0.01 or 0.02, and we're not going to sweat it as long as you show me the work, okay? I want you to try this one. I want you to try that one, and I will give you the answers so you know you're doing it right. So I will tell you that right here, side C is 32.22 inches. Angle X and angle Y are still to be found, right? So those are 53.84 degrees and 23.16 degrees. I will tell you that if you use sine law, the angles are different by 0.01. It's not a big deal, right? So these are your answers if you want to try it right now to see if you're doing okay. And the homework, no homework maybe? No, I'll give you a little bit to do, okay? I'm going to stick to this book, okay? So I'm going to ask you to do obviously this page, but homework, I'm going to go from 13 to 16. There's some finding height in the notes, right? There's some finding height. If you go way to 16, oops, I'm giving you the answers, but that's okay. I'll scan it anyways. There's some finding height and all kinds of different things. Actually, 16 is worth your time because I'm actually asking to find X, which is just this stretch, and Y, which means you're going to have to split those, right, into two right triangles. That's it for today.